Hello, I am Dr. Bob. I am going to show you how to install and set up the Yuasa Stretching Test Jig ST. I will be using the motor drive unit DMLHP. We are starting with the two pieces separated as if you have just removed them from their shipping boxes. Place the motor unit on the left with the power cord connection on the left. Place the ST jig on the right with its moving clamp on the left and the fixed clamp on the right. This is the way the units will face when they are joined together. There are only a few tools and parts you will be using. First is a T-type hexagon bar wrench. I call it an Allen wrench. It is a 3mm hex wrench. Second is an open-end wrench, 8mm on one end and 10mm on the other end. This is the linear output shaft, which is used when the DMLHP is used in the linear reciprocating mode. Only attach the linear output shaft when it is being used. It attaches through a hole in the motor unit. The ST is driven by the linear drive output of the motor unit, so we will be using the linear output shaft in this video. Make sure you never ship the motor unit with the linear output shaft attached. You can damage the motor unit and the shaft. This is a cover for the rotary reciprocating shaft and its screws. This cover should be attached over the rotary shaft on the motor unit for shipping. These are screws that will be used when joining the motor unit to the jig. This is the motor unit AC power cord with a 3-prong to 2-prong adapter for use when needed. All those parts should be in the motor unit shipping box. The following items are parts for the ST jig. This is the joint bracket, which will attach the ST jig to the motor unit. These are the screws to attach the joint bracket to the jig. This is the floating joint, which goes on the end of the linear drive shaft and couples to the moving slider of the ST jig. These are the clamper bases, and these are the clamping bars. These are squashing gauges, which will be used to equalize the clamp pressure across the sample. This is the minute adjuster, which will help us make very small changes in the fixed slider position to remove sagging of the unstretched sample. And there is a cover for the entire ST jig. For your safety, the cover should be placed on the jig anytime the jig is operating. Indeed, the jig will not operate if the cover is not in place. For this video, though, I will be able to use the jig without the cover so you can see the operation of the jig better. All those items should be in the ST shipping box. The motor drive DMLHP can be used in the linear reciprocating mode or in the rotary reciprocating mode. Converting from one to the other is easy. For the linear reciprocating mode, you install the linear reciprocating shaft through the hole on the front of the motor unit, attaching it internally to the linear guide. And you install the rotary shaft cover over the rotary reciprocating shaft on the left side of the motor. And you set the motor unit for linear drive using the touch panel. For the rotary reciprocating mode, you remove the linear reciprocating shaft and you remove the rotary shaft cover. And you set the motor unit for rotary drive using the touch panel. Please refer to the DMLHP motor drive unit setup and operation video for information on how to use the DMLHP. That will not be covered in this video. Place the motor unit on its side, not its back. You could damage the connectors. Attach the joint bracket. The attachment point is on the bottom of the unit below the linear drive shaft opening. Attach the joint bracket to the motor drive using 2 screws. The screws may already be in the motor. If so, remove them. Tighten the screws with 3 Nm torque. Attach the floating joint to the linear drive shaft. Tighten with 9 Nm torque. Then insert the linear drive shaft into the opening of the motor drive and attach it. Tighten the linear drive shaft, not the floating joint, with 9 Nm torque. Push the linear drive shaft into the DMLHP. With the DMLHP turned off, this will be easy. With the DMLHP turned on, you will not be able to move the shaft. You will use 2 screws to hold the ST to the joint bracket. They may already be in the ST. If so, remove them. Next, we will attach the ST to the joint bracket while we also insert the floating joint into the slot on the moving clamp of the ST. Push the moving slider to the end. Lift the left end of the ST over the joint bracket and insert the floating joint into the moving slider. You might need to move the shaft or the moving slider to do this. Then lower the left end of the ST over the joint bracket. Push the moving slider back to the other end. Install the 2 screws that hold the ST to the joint bracket. Tighten them with 3 Newton-meters torque. Our next step will be to prepare the ST for a sample. Before we mount a sample, let's look at the parameters involved in stretching. The minimum sample length is determined by the minimum distance between the sample clamps on the clamping plates. That is 30 millimeters. The maximum stretching distance is determined by the maximum stroke or reciprocating distance of the DMLHP. That is 120 millimeters. The longest unstretched sample length is determined by the maximum possible distance between the sample clamps, not the clamping plates. That is 365 millimeters. And that 365 millimeter sample could be stretched only by 0 millimeters. A 364 millimeter sample could be stretched by 1 millimeter. Likewise, the longest stretched sample length also will be 365 millimeters. The maximum stretching percentage capability of the ST is available with the shortest sample and the longest stretching distance. In this case, a 30 millimeter sample can be stretched 120 millimeters to become 150 millimeters, 400% stretching. As the unstretched sample length increases, the maximum stretching percentage decreases. The maximum tension with the DMLHP is 70 newtons or 15.7 pounds. The maximum speed is 90 reciprocations per minute. All these numbers arise from the specifications, mechanical and electrical, of the DMLHP-ST test machine. During the rest of this video, so I don't have to keep saying plus the clamping distance, most of the time I will not include the clamping distance in the values. Always remember, though, to include the clamping distance when you are actually preparing a sample. The numbers we will be working with are L sub U, the unstretched sample length, L sub S, the stretched sample length, stroke, which is the reciprocating distance, and S%, which is the stretching percentage. For stretching, we must specify 2 of these 4 numbers. Often that is the unstretched sample length and the stretching percentage. The equations for determining the other 2 values are then LS equals LU plus LU times S%, and stroke equals LU times S%. You might start with the unstretched length and the stretched length. Then stroke will be LS minus LU, and the S% will be LS minus LU divided by LU. When using these equations, keep in mind the limits. The minimum LU is 13 millimeters. The maximum stroke is 120 millimeters. The maximum L sub U is 365 millimeters. The maximum LS equals 120 millimeters plus L sub U if the sample is less than 245 millimeters. Maximum L sub S equals 365 millimeters minus L sub U if the sample is more than 245 millimeters. I have provided 2 figures for your convenience in determining the stroke or reciprocation distance and stretching percentage. Use figure 1 if the stretching percentage is going to be less than 100%. In the figures, the maximum stretching percentage is shown with the red curve, and its value is on the left vertical axis, also in red. The stroke is shown with the green curve, and its value is on the right vertical axis, also in green. The horizontal axis is the unstretched sample length. If you have a specific sample size, find that value on the horizontal axis, unstretched sample length. Go up until you reach the red curve to determine the maximum stretching you can achieve with that sample. That value will be on the left axis. Go up or down until you reach the green curve to determine the stroke or reciprocating distance for maximum stretching. That value will be on the right axis. If you want a specific stretching percentage, find that value on the red left vertical axis. Go across until you reach the red curve to determine the unstretched sample length for maximum stretching percentage. That value will be down on the horizontal axis. Go up or down until you hit the green curve to determine the stroke or reciprocating distance for maximum stretching percentage. I will demonstrate the ST setup using an unstretched sample of 140 millimeters provided by liquid wire, and I will stretch it 20%. I have placed a blue vertical line at 140 millimeters, and you can see that 20% stretching is below the red curve. I will need to calculate the numbers. For 20% stretching, the stroke will be 20% of 140 millimeters or 28 millimeters. The stretch sample length will be 140 millimeters plus 28 millimeters or 168 millimeters. Use figure 2 when the stretching is going to be greater than 100%. The example shown with the black lines here is a 50 millimeter sample that can be stretched a maximum of 240%. You can see that by going up the black line to the red curve, then following the black line to the left vertical axis. Continue to follow the black line up until you reach the green curve and follow that to the right vertical axis, and you can see that the stroke would be 120 millimeters. If you want to stretch the sample less than the maximum percentage stretching, use a smaller reciprocating distance. You can use the equations to calculate the values. I will demonstrate the ST setup also with a short, flexible fabric sample stretched 100%. The unstretched sample length is 65 millimeters, and I will stretch it to 130 millimeters. Following the blue line, you can see that 100% stretching is below the red line. Calculating the numbers, the stroke is simply 65 millimeters, the amount of the stretching. We are ready to mount our first sample, the liquid wire sample with 140 millimeter unstretched length and 28 millimeter stretching. Make sure the fixed slider is set to the far right position. Place the clamper bases on the sliders if they are not already there. They are already there, but I will check the tightness. Tighten them with 3 Newton meters torque. Place the clamper bars on the clamper bases. One is already there, but I will install the other one. Install the minute adjuster. Turn on the DMLHP and set the motor drive to linear drive mode. Set the plus SP position to be 120 millimeters. Set the minus SP position to be 120 millimeters minus 28 millimeters or 92 millimeters. Set the stop position to be minus. I will need to hold the minus jog button until the moving slider has reached its end at the right. But first I want to hold the plus jog button to go back to 120 millimeters, then the minus jog button to go to 92 millimeters. Move the fixed slider such that the clamping bars are 140 millimeters apart, the length of the unstretched sample. I need to adjust the screws. Let me check again to make sure the spacing is 140 millimeters. Adjust the minute adjuster position to the middle of its range. Tighten it with 3 Newton meters torque. I am making sure that it is still 140 millimeters. Adjust the minute adjuster dial to 0 so that it shows this initial position. Place the squashing gauges over each side of the clamping bar on the fixed slider. Set the squashing gauges to 0. Lift the clamping bar and slide the sample between the clamper base and the clamping bar on the fixed slider. You could start with the moving slider side. It does not matter which side you do first. Hold the clamping bar down evenly on the sample. The squashing gauges will show the sample thickness. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. Place the squashing gauges over each side of the clamping bar on the moving slider, or the fixed slider if you started with the moving slider. Set the squashing gauges to 0. Lift the clamping bar and slide the other end of the sample between the clamper base and the clamping bar moving slider. Hold the clamping bar down evenly on the sample. The squashing gauges will show the sample thickness. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. The sample will likely sag after you tighten the clamping bar. Make sure the minute adjuster is still set at 0. Then make the sample tight by slightly moving the fixed slider away from the moving slider using the adjusting screw. Note the reading on the minute adjuster. 1 full turn of the dial is 1 millimeter motion of the fixed slider. I had to move it 1 millimeter to tighten the sample. The difference is how much the fixed slider needs to move to eliminate the sample sag. Move the fixed slider back toward the moving slider until the minute adjuster reaches 0. Then continue to move the fixed slider toward the moving slider, the same distance that was required to tighten the sample 1 millimeter. I need to remount the sample. It does not matter which side I remount. I mounted the side with the wires first to make it easier for me, and I am remounting the other side also to make it easier for me. Lift the clamping bar and slide the sample between the clamper base and the clamper bar. Hold the clamping bar down evenly on the sample. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. Now move the fixed slider back to its previous position, using the minute adjuster to accurately set the position back to 0 on the dial. The sample should now be flat. Note that this sample has wires so that you can perform an electrical measurement during the test. I will attach the wires to clip leads from a Hioki RM3545 to monitor the resistance during the test. I have mounted the liquid wire sample. I have connected the Hioki RM3545 to the sample using the front panel connections. I could use a computer to run the test and collect the data, but in this case I will simply do a continuous measurement of the sample resistance. I will run a slow test so you can see the resistance change as the sample is stretched and relaxed. I have set the DMLHP count to 0 and the target to 8 reciprocations, and I have set the speed to 30 reciprocations per minute. At this point, you would place the cover over the jig for the safety of the operator. For this demonstration, though, I will leave the cover off so the camera can better capture the view. Press Start on the DMLHP and then confirm Start. The ST is stretching our 140 millimeter liquid wire sample by 28 millimeters. That's 20% stretching, 10 times at a speed of 30 per minute, from 140 millimeters to 168 millimeters. You can see that the resistance is changing as the sample is stretched and relaxed. About 33 ohms when stretched, and about 25 ohms when it is relaxed. If I used our ECP2 software, I could control the motor jig with a computer while making and recording multiple measurements during the test. For example, I could mount 3 or 4 samples during the same test run and make measurements on all of them. And this test is complete. We are ready to mount our second sample. I have already removed the first sample. This sample is a flexible fabric. The sample length is 65 millimeters, and I will stretch it to 130 millimeters, a stretching percentage of 100%. Make sure the fixed slider is set to its far right position. Set the DMLHP plus SP position to be 100 millimeters. Set the minus SP position to be 100 millimeters minus 65 millimeters or 35 millimeters. I cannot set the plus SP to be 120 millimeters as in our first test. The sample is only 65 millimeters, and the fixed slider would not move far enough to reach the sample. Set the stop position to be minus. Hold the minus jog button until the moving slider has reached its end at the right. Move the fixed slider such that the clamping bars are 65 millimeters apart, the length of the unstretched sample. You may need to adjust the minute adjuster position to the middle of its range. If so, tighten it with 3 Newton meters torque. Adjust the dial to 0 so that it shows this initial position. I'm checking to make sure the spacing is still 65 millimeters. Place the squashing gauges over each side of the clamping bar on the fixed slider. Set the squashing gauges to 0. Lift the clamping bar and slide the sample between the clamper base and the clamping bar on the fixed slider. Hold the clamping bar down evenly on the sample. The squashing gauges will show the sample thickness. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. Place the squashing gauges over each side of the clamping bar on the moving slider. Set the squashing gauges to 0. Lift the clamping bar and slide the other end of the sample between the clamper base and the clamping bar on the moving slider. Hold the clamping bar down evenly on the sample. The squashing gauges will show the sample thickness. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. The sample will likely sag after you tighten the clamping bar. We will repeat the minute adjuster procedure we did with the first sample. Make sure the minute adjuster still is set at 0. Then make the sample tight by slightly moving the fixed slider away from the moving slider using the adjusting screw. Note the reading on the minute adjuster. I moved it 0.5 millimeters. The difference is how much the fixed slider needs to move to eliminate the sample sag. Move the fixed slider back toward the moving slider until the minute adjuster reads 0. Then continue to move the fixed slider toward the moving slider, the same distance that was required to tighten the sample, 0.5 millimeters. Unmount the sample, then mount it again. Lift the fixed slider clamping bar and slide the sample between the clamper base and the clamping bar. Hold the clamping bar down evenly on the sample. Tighten the clamping bar screws to hold the sample, making sure that the squashing gauges read the same on each side. Now move the fixed slider back to its original position using the minute adjuster to accurately set the position back to 0 on the dial. The sample should be flat. Check to make sure we are still at 65 millimeter spacing. We are ready to run our second test. Set the DMLHP count to 0. Set the target to 25 reciprocations for this test. Set the speed to 40. That is the maximum speed the DMLHP can run when the reciprocation distance is 65 millimeters because the stepping motor is acceleration limited. As before, at this point, you should place the cover over the jig for the safety of the operator. For this demonstration, though, I will leave the cover off so the camera can better capture the view. Press Start on the DMLHP and then confirm Start. The ST is now stretching our flexible fabric sample by 100%, double the size, 25 times at a speed of 40 per minute. And this test is complete. This concludes the Yuasa ST setup video.